Now we're going to tackle the harder part of rational expressions. We're going to add or subtract. And to add or subtract fractions, you got to have common denominators. If I have a over b plus c over b, because the denominators are the same, we just keep the denominator, and then we add the numerators, a plus c. If this was a minus, that would just be a minus. If the denominators are common, you're good to go. But you might run into a problem where you have a over b plus c over d. Now the denominators are not common. So an easy way to find a common denominator, it might not always be the least common denominator, but is just to multiply these together. So our denominator is going to be b times d, whatever they are. Now to find the numerator, we just sort of multiply like we're cross multiplying. I like to go up to the left first. So this would be a times d, and then because we have a plus here, it's nice and easy, we just put a plus, and then we multiply on this diagonal, b times c, bc. So that's the pattern to follow. Multiply the given denominators, and then multiply up to the left and up to the right to fix your numerators. A word of caution though, if that was a minus in there instead, a over b minus c over d, the common denominator would still be those multiplied together, bd, and we'd multiply up this way, ad. But careful with the minus. Since this is a minus, you'd have minus. Whatever comes after that should be parenthesized off. If I multiply up this way and I have c times d, I want to make sure if there's a plus or a minus in here, I distribute that negative. Watch out when you're subtracting these rational expressions. And you'll see that pop up in an example or two. Actually, it looks like we're going to see it right here. We have one fraction minus another fraction, x over quantity x minus 3 minus this other fraction, 2 over 3x plus 4. So the first thing we want to do is get that common denominator. I'll just come right here underneath it, and I'm going to multiply these together in parentheses. X minus 3, and then 3x minus 4. To find our new and improved denominator, first I'm going to multiply up to the left this way, and I'm going to have x times the quantity, 3x plus 4, and then minus here, and I'm going to multiply on the other diagonal. And this is where that minus comes in critical for distributing. We're going to have 2 times that quantity x minus 3, 2 times the quantity x minus 3. All right. You might instinctively think, okay, we just did a bunch of canceling. Can I cancel x minus 3 and x minus 3? No, you can't, because this numerator has 2 separate terms. That's a term minus another term. We'd have to cancel an x minus 3 out of this term. Cannot cancel that x minus 3. But we can try to clean it up a little bit. I'm not going to FOIL out that denominator, but I can, distribute in this numerator, and especially this negative 2, and maybe I can simplify that down, then maybe get it to cancel a little bit later. So I'll just come right here underneath it. Distribute the first x, so that's going to be a 3x squared plus 4x. And then distribute the minus 2, minus 2x plus 6. And I'm just going to leave that denominator alone in hopes that something is going to cancel at some point. But if it doesn't, that's okay too. Okay, that numerator, we can collect some like terms. We have a 3x squared. That's our only squared term. It stays. 4x minus 2x is plus 2x. And then we have our constant plus 6. All divided by that quantity, x minus 3, quantity 3x minus 4. Now the question is, can we cancel or factor that numerator anymore? I'll just come down here and do a little scratch work. We have a 3x squared. That's got to be 3x and 3x. If we're looking at this, we have a 3x minus 4. Is 4 a factor of 6? No. Let's concentrate on this other one, x minus 3. Is it possible that this is a minus 3? Minus 3 times what is plus 6? This might be a plus 2. If our middle term works out. So our outer term would be a 9x plus 2 more. No, it doesn't work. We cannot factor that numerator anymore. So we're done. That's as simple as we can make it. We got a little warning here. What does this say? When subtracting rational expressions, remember to distribute the negative sign to all terms in the quantity that's being subtracted. That's huge. Very easy to make that mistake. I see it every year, time and time again. For 3 or more fractions, or fractions with a repeated factor in the denominator, the LCD method works well. Recall that the least common denominator of several fractions consists of the product of all the prime factors of the denominator, with each factor given the highest power of its occurrence in any denominator. And here's a numerical example. Or I might do this slightly different than the book. If I look at my denominator, I can just multiply my 3 terms. 6 times 4 times 3. Those are my 3 denominators multiplied together. This numerator already has the 6 from the denominator. So I have my numerator that was a 1. Under it is the 6, but what was it missing underneath it? The 4 and the 3. So I'm going to multiply this numerator by the 4 and the 3, what it was missing underneath it. And then we have a plus. Our numerator here is a 3. And what's missing from its denominator? It has the 4, but it's missing the 6 and the 3. So I'm going to multiply that by 6 and by 3. Minus. This numerator was a 2. Its denominator was a 3. So what pieces is it missing? 4 times 6. So this times 4 times 6. And then we could, crunch those numbers out and reduce the fraction. But we're looking at, there's 3 pieces to the denominator. This numerator has one of the pieces. We're going to multiply that numerator by the pieces that are missing from underneath it in that denominator. So let's try that here with this one. I'm going to write this again because this last term, we can mess around with that denominator a little bit to make this problem somewhat easier. This denominator is x minus 1 minus 2. This denominator is just an x. Here we have x plus 3. This denominator we can factor. X squared minus 1 is x plus 1, x minus 1. So now let's figure out what the common denominator will be. And this is going to be a little different because we have this x plus 1, x minus 1, and here's just an x minus 1. So we need one of each of these in the denominator. We have an x term from right here. We have an x plus 1 and an x minus 1. We have an x plus 1 and an x minus 1. So let's work on our numerators. This numerator was a 3. Under it was x minus 1. We have this piece. So we multiply the 3 by the 2 pieces that it's missing, x and x plus 1. And then we have a minus. Numerator's 2. Under the 2 is x. What are we missing? X plus 1 and x minus 1. X plus 1 and x minus 1. And then we have plus, extend this out. The numerator we already have is x plus 3. What are we missing underneath it? Well, we have x plus 1, we have x minus 1. We're only missing the x. So that gets multiplied by x. All right. Move that up. And I drop this. There we go. So let's simplify that numerator a little. So I'm going to switch over to different color. Denominator will not change yet. X times x plus 1 times x minus 1. And let's see here. Let's look at this as a 3x and distribute across the parentheses. 3x times x is 3x squared. 3x times 1 is plus 3x. We have an x plus 1 and x minus 1. If we FOIL that out, we get x squared minus 1. And then we can just distribute the 2 across that. So we're going to have a minus 2x squared. Minus 2 times minus 1 is plus 2. And then we distribute this x across the x plus 3. Plus x squared plus 3x. So now it sure looks like we can combine some of those numerator terms and then see maybe somewhere along the line we'll have something cancel. We don't have to have that happen though. Okay. Denominator we will leave the same. Let's see up here, our biggest term is squared. 3x squared plus x squared is 4x squared. Ooh, and I missed that right there. We have more than that. So 3x squared plus 1x squared is 2x squared minus, or 4x squared minus 2x squared is 2x squared. So we just have a 2x squared there. And then we have a 3x and another plus 3x, that's plus 6x. And then our only constant is the plus 2. So that is all over our denominator. Let's see, I guess we could factor a 2 out of there, right? That's not going to hurt anything. It doesn't mean we're going to be able to cancel with anything in the denominator, but if we can factor out a common term, we're going to pull out a 2, so we're going to be left with x squared plus 3x plus 1 over our denominator, x times x plus 1 times x minus 1. Our trinomial in the numerator can no longer be factored any farther. Nothing's going to cancel right now, so that is our final answer. And now we have complex fractions and the difference quotient. Complex fractions are fractions within fractions. So here we have a fraction line. The denominator is just a polynomial, but the numerator is another fraction, a fraction within a fraction. And here's even more complex. Our numerator is one fraction, and then we have our divider line, and then our denominator is a completely different fraction. So to simplify a complex fraction, combine the fractions in the numerator into a single fraction, and then combine the fractions in the denominator to a single fraction, then invert and multiply. Alrighty. So, I'm going to write this out, make sure we go over this completely step by step by step. This numerator is 2 over x minus, and we can write 3 as 3 over 1. And I'm going to switch to red for the denominators. Here we have 1 over 1 minus 1 over the quantity x minus 1. So we're going to combine the numerator into its own fraction, single fraction, and then combine the denominator into its own single fraction, and then fractions divided by fractions you invert and multiply. So let's see here, just the numerator, our denominators are x and 1, so we multiply them together and get x. And then we multiply up. 1 times 2 is 2. This x times negative 3 is negative 3x. And I'll make this a double line. So there's the numerator of our complex fraction. And now on to the denominator. Nice, here we have a 1, so we multiply these together to get our common denominator. Common denominator is quantity x minus 1. Numerator multiply up. 1 times x minus 1 is x minus 1. And then we have 1 times minus 1 is minus 1. And we can combine that. X minus 1 is x minus 2. So let me just write that as x minus 2. So I think the hardest part is over. Fraction, or the numerator is now a fraction. The denominator is now a different fraction. So we're ready to divide. Fraction divided by a fraction. Oops. Invert and multiply. I guess we can put it right there. So the numerator is going to stay exactly the same. 2 minus 3x divided by x. And this is divided by, so we bring it up and we make it into a multiply and we flip it over. So now x minus 1 is in the top and x minus 2 is in the denominator. And let's see, on the diagonal, nothing's going to cancel. Nothing cancels above and below. So it looks like we're just going to multiply straight across. We're going to have x minus 1 times quantity 2 minus 3x divided by x times quantity x minus 2. And there's our final answer. You know, complex fractions, or fractions within fractions. We turned all this mess into this. You know, it doesn't look a whole lot prettier, but we don't have a complex fraction anymore. Time for some practice. So perform the addition or subtraction and simplify. Remember, this is a minus 5 or minus 5 over 1. So be careful, extra careful with the subtraction one here. This plus 1 isn't bad. And there is a trick to this one, to the denominator. There's two different routes, at least two different ways to do this. You know, pick one. You know, we'll see what we come up with. We'll go over them both in class. And the last one is a complex fraction. So pause the video, give them a shot, and then see how you did. All right. So the first one, this is negative 5 over 1. Common denominator, multiply the two that we got. 1 times the quantity x minus 1 is just the quantity x minus 1. Multiply up to the left. 3 times 1 is 3. And now here we have our minus 5 times the quantity x minus 1. Don't forget to distribute. Don't even think about canceling on that diagonal because we have two terms in the numerator. So we have 3. Distribute the minus 5. Minus 5x plus 5 all over quantity x minus 1. And it looks like 5 and 3, we can combine that into an 8. Our numerator is 8 minus 5x divided by x minus 1. And there's our final answer. All right, 61. Let's do it the long way first, and we're just going to do it with the pattern that I showed you, and it will work. So we have two denominators right now. If we multiply them together, we get x minus 2 times 2 minus x. And then we multiply up to the left. We're going to have that numerator 3 times the 2 minus x. And then we're going to have the plus 5 times x minus 2. In the numerator, try to simplify it a little bit. Distribute the 3. So that'll be a 6 minus 3x. Distribute the 5 plus 5x minus 10 over this denominator. X minus 2 times quantity 2 minus x. I'm going to work over this way. Collect up all our like terms. Minus 3x and 5x is 2x. 6 minus 10 is negative 4. All over our denominator. X minus 2, 2 minus x. Okay. It looks like we can factor a 2 out of the numerator. I'm going to hop up here. Factor out a 2. 2 times the quantity, x minus 2, over, ooh, look at that, quantity x minus 2 times quantity 2 minus x. And it looks like we're going to have these cancel, and we're left with 2 over 2 minus x. 2 over quantity 2 minus x. Okay, that's one way to do it, and that's kind of the long way. That took quite a bit of doing. There is an easier way. I can't remember if it was an earlier video. I don't think it was this one. These denominators are very, very similar right now. What can we do to this second denominator to have it look like the first denominator? Here's an x minus 2, and we got a 2 minus x. Remember, we can factor out a negative. If I pull a negative out, the x becomes positive. The positive 2 changes to negative. And look at that. Now we have 3 over a denominator plus a negative 5 over the same denominator. So this negative is sort of going to overpower that plus sign. We're going to have 3 over the denominator x minus 2 minus 5 over the denominator x minus 2. Denominators are already common, so now we just subtract. 3 minus 5 is negative 2 over the quantity x minus 2. But look, that's not exactly what we found the other way. We have this and this. What's the difference? We have this negative sign, and the denominator looks like it's flip-flopped. Well, that's an easy fix. I can take this negative, move it down here, and distribute throughout the parentheses, and then it would be 2 minus x. Or I could factor the negative out of this denominator from our first way we did it, and it would look exactly the same. Either way, if you gave me an answer like that on the test, I would accept it full credit. And the last one, complex fraction. Get some of this out of the way here. Oops. There we go. All right, I'll use red for the numerator. So here we have x over 2 minus 1 over 1. Denominator is x minus 2, and I'll put that over a 1. So we really only got to deal with that numerator. This will be a little easier than some of the examples. Oops, so red for the numerator. Denominators that we have are 2 and 1, so I multiply them together and get a 2. Numerator, multiply up. 1 times x is x. Minus 1 times 2 is minus 2. Over, ooh, look at that, quantity x minus 2 over 1. So a fraction divided by a fraction. I'm going to bring the bottom one up, invert, and multiply. So my numerator was x minus 2 over 2. I was dividing by this, I bring it up, and now it's multiplied by the reciprocal. 1 over quantity x minus 2. Oh, beautiful. Look at that. X minus 2's on the diagonal cancel out, and we're left with a nice, pretty 1/2. 1/2 is the final answer. Nice. All right, assignment for this, P5 Day 2, page 49. You know, there's just a few of them, but they are a little more complicated problems. Take your time with them. Make sure you really understand them, especially 48, 62, and 64. Those are even ones. Answer is not in the back of the book.